Hi there, this is session 11 of programming from the very basics using Python. In this video, you'll learn more about compound statements, the general structure of how all compound statements look and their syntax and semantics in general. And we'll also look into basic flow control using if condition, while loop, and the very basic usage of for loop, just to get started, right? So first I'll talk about compound statements itself. All compound statements in Python, they have a particular format to them. They all start with a keyword, one of the keywords. The keywords could either be, if, while, for, try, with, and what else. These are the flow control construct keywords. And you would also have some more keywords like def or another modern variant called async def available from Python 3.6 and class. So these statements start with any of these keywords followed by their own syntax grammar. If expects a conditional expression, so does while. And if you look at things like try, they don't expect anything. For has a special syntax where you say for element in iterable. So you would actually use a special syntax grammar for that. Def class, they take a name, which will be an identifier that will be defined. So does async def. And with would also take an expression that manages context. So it varies. For now, all the compound statements start with either of these keywords followed by their own syntax grammar. But what you will see there is that what you'll also find is that they have a prologue to them, which ends with a colon, followed by either a line of code, one single statement, or you need have an indented block. So I would actually put it like this. You will actually, if you look at the syntax grammar for it, let me make this a markdown rather. So I can just use some proper documentation here. I will just say all compound statements start with one of the keywords, which could be if, while, for, try, with, def, async def, and class or class. I'm not sure if I missed any keywords in here, but let's just look. Okay, so I'm just trying to be dynamic, so spontaneous at this moment. So it's possible that I would have missed a keyword or two, but these are the most common keywords that come to my mind when you think of compound statements, right? They start with these keywords and they would follow a syntax that looks like this. The grammar, or the structure, right? Or rather, the structure would be as below. I'm just going to use some kind of a block semantics here like this. They're just markdown ways of using a pre-processed code which maintains all the formatting, right? So it will start with a keyword, and followed by keyword specific syntax. And they end with a colon. This is called as a prologue that ends with a colon, followed by a simple statement. This is one format. Or another form that would be there is as usual. I'll just repeat this whole thing. Keyword specific syntax followed by a colon, but you could have a block of code represented as an indented block. Indented block of statements that make up the body. These are two forms, that is it. So you can actually see that you can have multiple simple statements or nested compound statements inside this block. and they end with unindentation. The moment you unindent, they end right there. So these are two forms of structure that is it. Oh yeah, this looks very theoretical and very, what do you say? Uh, it's not very practical, right? So I'll give you some practical examples at this moment. Once you see once I give you a practical example, then you'll actually see how they fall into the same structure. Let us say that I want to use the if condition or if statement. What is the use of if statement? Well, the if statement is used for checking conditions. Oh, we already did that with the ternary if expressions in the previous sessions. I think it was in session 9 again. So when I talked about the ternary if expression, I told you it's a ternary expression that takes three operands, right? Basically, you have a true expression, if, condition, else, false expression. If you remember the example I showed you in the session 9, just a quick repeat, is maybe I have a number. I say num is equal to 34. I want to check whether the number programmatically, whether it's even or odd. I told you you could find that by using this expression where you could just return even if num percentage 2 equals 0, or I can say else you could use odd. As you can see here, again you can see that I use this ternary if expression in here, and this returns an expression if this conditional statement is true, a conditional expression is true. There's a Boolean expression, right? If this returns true, it evaluates what is supposed to be here, the true case. If this particular expression evaluates to false, whatever you find after else clause, that would be evaluated. We learned this pretty much for a long, with a lot of examples, right, in the session 9. But what you should also note here is that this ternary if expression is quite limited in its functionality, because all you have here is a single expression that you can use here or another expression here. What if I have a use case scenario where I want to execute a block of statements, multiple statements, if some condition is met? Well, you can't do that in here. One ways you can do that is you can create a function, put all those chunks of code in a function and invoke the function here. That's one possibility. But sometimes you don't want to create too many functions. You just want to have a block of code to be executed if a condition is met, else you want to do something else. Or maybe you want to chain load multiple conditions. Check if one condition is true, then perform some activity, else check another condition is true, perform some other activity, and so on. With the ternary if expression, just the usage is quite limited. It's only used for very simple use cases like these, and that's exactly where the if statement could be used. So let me give you a small example. Let's say that I want to greet a user. I want to greet a person based on his age or his or her age, right? So let's get the age of the person from user input. So let's say age is equal to int of input of enter your age. I know some of you might argue and say, oh, well, this is not very polite. Yeah, in real world, it may not be, but it's a program after all. So you can just take it as a joke. And now I can just check if age is less than 0. Well, if the user says my age is minus 10, what does that really mean? Well, I don't know. So you can just print a message like this. Are you out of your mind? I know it's not very polite. Just consider this as a joking program, a program that has a little bit of wit and humor. Now, when I say if age is less than 0, I say print, are you out of my mind? Let's stop at this, right? Let's try to test this. I try to run this program, run this cell rather. When I try to execute it, control enter, you can see that it's prompting for enter age. I know it's a little counterintuitive. Enter age comes below, but you're supposed to type the input there, right? If you try running this in a terminal, this all looks good. If you put this in a .py file and run in a terminal, it'll prompt on a terminal exactly what's your enter your age, and you'll have the cursor blinking right there. So it's fine. We will do that later. For now, we'll test it on the notebook. So we'll give the input as, let's say, 10, and you'll see nothing happens. I mean, there's no output. There's no output. You know why? Because age equal to 10 does not satisfy this condition. This condition is false. Because this condition is false, whatever you put in this indented block of code is not executed in runtime, right? So if at all I just want to, let's try running this again and try to provide an age, let's say minus 10 for now, as I told you. Now it's going to print a message. Are you out of your mind? You can see that. So this particular print statement or this print function call is invoked only if this condition is met. The if clause or the if statement checks for the condition. If this particular expression evaluates to true in Boolean context, then it's going to execute whatever code you put inside this block. And I use the word block here. What is a block? Anything that's indented. The word indented means that you're trying to use some spacing to specify the block of control here. Some of you might wonder, what if I don't have this indentation? If I just put this print statement right here, what do you think is going to happen? You can already see that the VS Code is highlighted with a red, indicating that, oh, this is not going to work. It sort of guessed it, and it's right. So if you try running this now, you can see that it throws off a syntax error, not even a runtime syntax error. Actually, it's called an indentation error. It's not really a syntax error, it's indentation error, but it's caught during parse time. I would have told you that when a program is being parsed in Python, during parsing of your program source code, the Python parser is going to check whether your syntax grammar is correct. It's also going to check whether you're using the proper indentation rules. If any of them fail, it stops right there. It does not even execute a single line of code. For some of you who come from other language backgrounds like C or C++ or JavaScript and Java, all these other languages, this might look a little weird because in other languages, you use some kind of syntax sugar for representing block, like open curly brace, close curly brace. That's pretty common. And there are other languages which use some words like begin end blocks, Pascal. And to some extent, even Ruby, you just start a block and you end a block by using end, right? So it varies, or do end blocks. But in Python, you don't have any special keywords. The indentation decides the scope of this block. Now, how many spaces should you really use? Well, even if you use one space, it's going to work without a problem. So I just use one space here, one space, and execute this. It's prompting for user input. Let's try -3. Yeah, it's executed, as you can see here. Though you can simply use one space for representing the block, the indented block, the most agreed upon convention is to use 4 spaces. Okay, unless you work at places like Google, I don't know why they use some 2 spaces or 3 space indentation for some strange reason, but I've seen a lot of these Python code that comes in from Google. I'm not sure if they changed recently, but I've seen all of the old code used to have lesser spaces. But if you look at the rest of the Python community, they have sort of agreed upon using 4 space indentation. You can put 1, 2, 3, 4 spaces. But you know what? If you have an editor or Jupyter interface or editor like VS Code or any programmer friendly editor that is that understands Python syntax rather, or Python based editors, I would say, you don't really have to manually put 4 spaces. You can use the tab key. When you press the tab key, it actually would insert 4 spaces. Or you have to check your editor settings. There are settings in your editor where you can configure all the stuff. Those of you who plan to use things like Vim or NeoVim or the old school VI editor, I think you need to go and check up your VimRC or those kind of profiles to set up your tab spacing, expand tabs, shift width 4, and all that stuff, right? Anyways, but if you're using VS Code, you don't have to worry. Or if you just use directly, if you use some ready-made plugins for your editor to support Python syntax support, I think they will take care of it naturally. So use just tab here to have that 4 space indentation, and it just works without a problem. Still, you can see that. If not, you have an if condition, just a simple if condition with just one single statement inside it. One single simple statement inside it, then you can also represent the statement on the same line. This is also a way of representing a compound statement block. So run this code now. You can try -5. It still works. If you try 5, you can see it does not print any output, right? So you can see that if your block is just made up of one single simple statement, you can put it right away on the same line. But if you plan to use this on the next line, this could be a reason why, because you don't just have one statement but multiple statements. That's the whole purpose of using compound statements like if, right? And then you need to have code that's indented. I'm going to use one more print here. I can put a value like, you can say age. I can just type maybe your age is invalid. Add another message like this. If you try running this, if I try maybe 5, it works. You can see no output. That means it works, right? If I try -5, you can see that the two print statements are printed. I can also add another print statement just for testing over here. I just say done. I'm keeping it as silly as possible, so you only focus on the syntax, nuance, and structure. I'm not focusing more on the logical things, right? As of now. We run this now, and if you try -5, you can see that all three print statements are part of the if block. So it executes all of them one after another. First print statement, are you out of your mind? Second print statement, your age is invalid. That's your age -5. Okay. And I'll say, I can rather, this doesn't read nice. Your -5. What is -5, right? I say, as an age is invalid. Maybe that makes sense. I said -5 here. -5 as an age is invalid. Yeah, reads better, and done. If at all I try to provide an age that's valid, for example, if I type 5, you can see that nothing comes up on the screen. Now I'll show you something. If I take this last print statement that's done, right? I'm going to just unindent it. So unindentation is done by putting a backspace. Just position a cursor here and put a backspace to go back to the previous level of indentation, right? Try running it now. And try 5, done. You can see that. So when I try 5, this particular condition is false. This condition is true, sorry, it's false. When I say 5, this condition is false because age is not less than 0. So obviously it's not going to execute these two print statements, but this print statement is outside the block. Therefore, this will anyway be evaluated. If you try to take this one out, you can see, though syntax wise is fine, semantically it may not be very correct. When I try 5, it says 5 as an age is also invalid, and it says done. But however, if you try something like say -5, whether you can see that these two statements are executed irrespective of what the condition is, because this statement is conditional, right? This block is conditional. I'm trying to say that whatever you put in this indented block will be executed only if this condition is true, but anything outside this block will be executed anyways, right? So this is what you should know about how the indentation decides the scope of a statement. So whether a statement is part of a particular block or not is dependent on the indentation level. In my personal opinion, and also my personal experience, this is a little bit of extra learning to do for people who come from other language backgrounds. If you're coming from backgrounds like C or C++, this might sound a little scary for first time. Oh, indentation. So I don't have this block specific, to say characters like open, close, curly braces and begin end block. So I need to worry about this indentation very well. And I will also show you one more interesting code here. Let's say I create a new file. I'm just going to show you a new file. I'm just going to put a space here, just a space, okay? And say print hello world. And let me save this. Let me save this as, oh, the dialog box goes behind as usual on my setup. Yeah. Let me call this as, I think I already have a file called hello.py. Let me call this as hello with a space. I put a space before the first statement here, right? Simple statement here. You can also see that the VS Code is sort of highlighted it in red. The space is highlighted in red, but to say there's an error there. In fact, when you position your cursor there, it says unexpected indentation. If you install the Python plugins for VS Code, it might come with some kind of a syntax checker. One of them is Pylance. So that's what is installed in this case. There are various syntax checkers available as plugins for the editors. This will dynamically keep checking whether your syntax grammar seems to be fine. Okay. So on even runtime ambiguities will also be tested by tools like these. So this could be quite convenient for those of you who depend on these tools. My suggestion, don't depend on this. If you should be able to write fluent Python programs without all these extra embellishments. That's what makes you a more fluent Python programmer, right? So it's just like a spoken language thing, right? If at all you want to speak very well, if you are to depend on some kind of a dictionary all the time that you carry in your pocket or some kind of grammar checker around and you are to keep reading through it and then speak, you're not going to be very efficient. The most fluent spoken person people are ones who can speak out. You can make a mistake here and there and you can always correct it back, right? Anyways, so if all I go to this place where I've saved this file, I'm in my Python samples folder here, as usual. That's where I've saved this file. So I can just type Python hello with a space .py. You can see it throws an error, which means that you shouldn't have spaces before a statement unless that statement is part of a compound statement block. It is not part of a compound statement. This print is not part of if condition or for loop or while loop. It's not inside a compound statement block. So it's invalid to have spaces before it. So you just have to remove the space to make it work. Just save it now and try running. It works. Whenever you get an error called indentation error, it's got to do with your indentation. Simple. You have indented unwantedly or you have not used an indentation where it's really required. That's the reason, right? So that's what you should know here. So the same is applicable even to cells inside a notebook, right? Anyways, so here I showed you how you can specify a block of code by using indentation and use for space indentation if at all your editor is not properly configured, right? And there are some old school editors. Windows Notepad is one such culprit. I've seen far too many people writing code even today in 2024 using Windows Notepad. Don't. At least install Notepad++ if you're using Windows, right? If you're going to be using a Python on Windows, if you're not using Anaconda, you're using your Python that you got from python.org, don't use Notepad. At least use the pre-built editor that comes bundled with Python called IDLE. It's called as IDLE. You can search for that. It looks like Notepad in a way. It has a very similar kind of a Spartan feel. It's got a very simple TK-based interface, right? And TK is a toolkit widget library, which of the 1990s, and it's there even today, right? It's used even today. It's an old school widgeting or graphical user interface library, but it's quite mature and it's quite easy to prototype GUI on top of it. So anyways, Python comes with TK bundled with the standard library. So idle is a tool that's built using it. And it looks like Notepad in a way. It also comes with a Python shell. You can use file, new, and so on. I can't demonstrate this because I don't have idle on Linux. Somehow it's broken. But if I could bring up my Windows virtual machine sometime later, maybe in the future sessions, I'll show you an instance of idle. It looks very basic. You can use that for editing your Python code, not Windows Notepad. Not. Okay. I'll tell you why. When you use these very simplistic or primitive editors, which are not really understanding about Python syntax as such. They're not programmers either. The chances are that when you press the tab key, they add a tab stop. They add a tab stop. A tab stop is generally about it spaces to 8 characters. That's the norm generally. And the problem with that is if you have one of the line with a tab stop and the second line using spaces, that leads to a lot of confusion. In the Python 2 days, all hell used to break loose where the code looks nicely indented when you look up in the editor. Nicely indented. I faced this a couple of times in the mid 2000 era. So the code looks properly indented, but when you run it, it throws indentation error. And the culprit is in one of the lines, use a tab stop. A tab stop is a single character. It's actually a single character that just puts a stop to 8 spaces. Whereas the next line has got 8 spaces. Python gets confused. Actually, if you use a tab stop and match it up with 8 spaces, there's not a problem. That did not cause much of a problem. But if you have some of these editors where you configure your shift width of tab stop to 4 spaces, a single tab stop will show up as 4 spaces in your editor, and below use 4 spaces to match up the indentation. That's the problem. That's what looks indented in your code in your editor, but when you run it, it throws an error with the indentation error. Now Python 3 has remedied this. In Python later editions of Python 2, they expect you to run with a Python -t switch, but in Python 3 you don't have to. If you mix tab stop and spaces in a single file, you get a special error called tab error. That also is a parse time error. It's difficult to do this on VS Code, so I'm not going to use VS Code. I'm going to just demonstrate this with a Spartan editor. Almost all my editors are sophisticated. Let me try Nano. Ubuntu comes with a silliest of editor called Nano, which I am still trying to get to like it. Every time I open up Nano, I feel like frustrated and go back to Vim. Okay, I'm a Vim guy. So, anyways, so I'll try to use Nano, and I'll just try maybe, tab and space.py. Tab doesn't put a tab stop here. So here I'm just going to print, same thing. I'll just copy this code. It saves me time, so I can just copy this whole code here and paste it off in this place. Yeah. Looks like there are 4 spaces here. So I'm going to substitute with this one with a single tab stop. There's actually a tab stop. You can see my cursor just hops over this area, right? That's one of the hint that you get with these editors with tab stops in place. And below, I'm just going to put like 1, 2, 3, 4, 5, 6, 7, 8. It looks perfectly indented, right? No problem at all. Let me save this. And zip. Control X. Okay. I'll try Python tab and space .py. You get this error. You get tab error. Inconsistent use of tabs and spaces in indentation. Here's a rule. If you do plan to use tab stops for indentation, maybe because it's a very old code, somebody had written with only tab stops back in the days, and you don't want to go all over and change everything to spaces, you should do it, but maybe you don't want to. Something can break, we don't know. You can continue using tabs, but don't use spaces, only use tabs. That means your indentation should only be made of tabs or only be made of spaces. You should never mix them because you know it's going to cause problems. So you better avoid it. So Python detects this. If the indentation is a mixture of tab stops and spaces, it'll not even continue. It'll just throw this error, right? So if you want to make this work, one option is convert all the tabs to spaces or convert all the spaces to tabs. I'm going to convert this to a tab now. Now both are having tab stops. Both of these indents are having tab stops. Save it. Exit. Now it works. As you can see. So the rule, if you want to use tabs versus spaces, you can only use tabs or only use spaces. Never mix them both. Right? Note this. And for all the new code that you write, it's suggested that you don't use tab stops at all because tab stops I've always had a history of being inconsistent amongst the way it shows up in editors. In some editors, the tab stop shows up as 4 space, or some editors show up with 8 spaces. So that is the argument. Yeah, the debate about tabs versus spaces is never going to end. There are some programmers who even today believe that tabs are the best form of indentation. A sideline, I think I remember watching one of these popular series called Silicon Valley. I'm not sure if you have watched that series. I'm not sure which OTT has that, but it's a very popular series. It was then the previous decade, I think in the 2010, 20, I think it's 2013, 2014 time frame. It was being aired, and one of the episode talks about tabs versus spaces. It's a tech series, of course. So it's a funny thing that I just thought about. Anyways, so don't mix them. So you can just use either tabs or only spaces. My suggestion: use 4 spaces for indentation. And this is not an editor suitable for writing Python program. Definitely not Nano. Maybe if you're just going to edit a line or two, fine. But you don't want to be developing code in Nano. Nano is not meant for that. Okay. Some people might argue against that, but Nano is more for simple text editing. That's what its intention is. You have a couple of these tools like Nano, Micro, and so on, right? This is like the command line version of Windows Notepad on Linux environment these days, suitable for systems administrators and a couple of basic users. Oh. And people like me literally struggle on it. I don't know what keystroke did I type. Okay. Should I say control W? Yeah, control W. No, it's not control W. What is it? Control X. Okay. Saved it. Okay, just type tab and space. View. Open up in that text editor, just show you. You can try the similar kind of an example with Windows Notepad if you want to, right? So let me leave this example with the inconsistent version. So it knows, you know that when you run this, you're going to get an error, right? So let me fix that. So I just leave the first line with tab stop and second line with 8 spaces. So to share this code, you can try it out. You get tab error. So there are basically 3 kinds of errors that are parse time errors in Python: syntax error, indentation error, tab error. So not a single line of code will be executed if these errors are encountered. So these errors are parse time, which means during parsing of your program, these errors are thrown. So not a single line of code is executed. Everything else is a runtime error: type error, value error, index error, key error. All of these are runtime errors, name error, right? But these 3 errors are parse time errors in Python, or compile time errors, if you want to call it that. Now I told you about the basics of indentation and things like that. Now we can just see, I can just say age is equal to int of input of entry age. I tried to check for the condition and I decided whether this code must be part of this if condition. Else, I can add an else clause. The else clause is at the same level as if. You can see this, same level as if. And here I can have a block of code. I can say, welcome, young Pythonista. Right? So it's very simple. If this condition is true, it'll execute all the code that is there in this indented block. Else, that means if this condition is not true, right, it's going to execute whatever you put inside the else block. And that's exactly if else statement is all about. So we try running this now. Try -10. You can see that it throws, it does not throw an error, it just prints this message, right? Are you out of your mind? -10 is 10 as an age is invalid. But when you try running it again, and if I try a number like say 20 is an age where you can just generally greet, welcome young Pythonista, right? But yeah, I know some of them are learning Python at the age of 10, a lot of them, right? Today. So programmers are becoming younger, right? So that's the difference. Anyways, so we can greet them as young Pythonista. But if you run this program with an age like, let's say 78, you don't want to know whether it's this person should be called young. Yeah, any age can be young. Age is just a number, people say. But maybe you want to greet, hello, Python guru, or hello, old Pythonista, or, I can say Python wizard, anything as such. So, I want to greet a user based on the age, let's assume. You just want to use different age groups for greeting the user differently. How do you do that? One of the ways is by chain loading this if condition. How? I can actually do this. I can say if age is less than 0, obviously it's invalid. You just ask out of your mind and say age is this age is an invalid number. But you can check if you can use elif condition. Elif. I could just type age is maybe less than 30 or less than some number, let's say 30. Hello, young Python. I can change the number. Whatever you think is young, you can change that, right? So I can put another elif. Age is less than, let's say, 60. Let's say print, welcome, Python guru. Elif age is less than, let's say, let's give a number like say 90 and say print, hello, Python wizard. Someone older than 90 working on Python? Wow. Let's try. If age is less than 150 now, say Python rules. Else, the only possibility is that age is less than 0. You can catch that with this number. If somebody types the ages like say 30 or 40 or 50 or 60 or 70 or 80, these conditions will catch them. It falls in those conditions. But if the age goes beyond 150, do I know anyone who's aged 150 years in this world today? I don't know. You just ask, are you human? So here's an example of how you can use if elif constructs to chain conditions and can run this. You can try different numbers. Let's try a number like say 20. When I type 20, it prints welcome young Pythonistas. You can see that because I took the input as 20 and this condition is not true, but this condition is true. It's basically the elif is very interesting to note. Some people might ask, why do you put elif? Elif stands for, it's a shorthand for telling else if. Different languages, the else if could be, say worded differently. In some languages, it is ELSEIF, else if, complete. Sometimes else space if, sometimes else and if put together as one word. ELSEIF is one word. Some languages, I can't recollect, many languages, so confusing. And some of them have ELSIF, else if, without an E there, was one word. Or some of them have elif. So different languages, different texts. So that's something to note. Python, it's elif. Elif stands for else if, the shorthand for else if. This else if means that, see, if we don't use elif over here, like this, if I keep it like this also would work. This also would work, but it's a little peculiar when you run this code. Let the else be there, okay? It'll be connected to this one. I just put some new lines to separate the blocks. It's a good idea. Whenever you have multiple blocks, to say that the block is ended, to make it more readable, it's suggested to have one blank line like this. Have one blank line to say, okay, this block is completed. So it looks more readable. Rather than cramming the code like this, it looks so crammed in, it's not readable, right? So it's just like you have paragraphs in English. Imagine writing a 5,000 line long essay or an article as one big long paragraph. Not very readable. Normally, when you're writing long essays or long articles, what do? You create paragraphs, right? You create paragraphs. It looks nice. It looks very structured to read. So it's always good practice to use this kind of structuring also in your code. So if you believe that there's a block, and if you believe the block ends, have a space here. I mean, a new line, right? Have a new line like this. Some of you might ask, should I put a else with a space? No, this else is with if. That's why I don't use a space. This is okay. But here, these blocks are separate, so that's why I'm using spaces. Now, when I run this, just observe what happens when I execute this code. If age is less than 0, are you out of my mind? Age is invalid. If age is less than 30, welcome young Python star. If age is less than 60, welcome Python group. Age is less than 90, welcome Python wizard. Now I'm going to try something. When I run this code and if I give a number like say -5, see what you get. Well, it prints everything. You know why? All of these conditions are true. When I give a value -5, this condition is true, these statements are executed. This condition is also true, so this statement is executed. This condition is also true because -5 is less than 60. Am I right? Yeah, it is. So this statement is executed. I don't want this. I want to check for this condition. If this condition is true, I want these set of statements to be executed. Else, if this condition is not true, but I want to check for another condition, right? Else if. That's what else if versus if is. So the moment you use else if here, I call this elif. Okay. So when I use when I say else if, I will be spelling elif, just like in English. Think of the S is silent or whatever. Okay. Elif or else if. Else if. Try running it now. If I try -5, you can see the output. It just shows, are you out of mind? -5 as an age is invalid and stops right there. It does not really check for any other conditions after that. If this condition is satisfied, it executes this block. It's not going to check any other conditions because they're checked only if this condition is not satisfied, checks for a second condition. If this condition is not satisfied, checks for the third one. If this condition is not satisfied, it checks for the fourth one. That's what else if does, right? You should know this very well. It is not just with Python. There's a common norm in every language, every programming language. The syntax grammar might vary, but the logic of execution, what I'm trying to teach you, is the same across all languages I've encountered, right? So when you use if elif, I would not suggest using spacing like this because technically there's like one block of code. It's okay to have it like this. Only when you have if statement, have a block, and there's another if statement. These two are two logically separate blocks, like two different paragraphs. So that's why I use a new line to separate them. But this elif is based on if. If the previous condition is true, I want to check for the next one. If this condition is not true, I want to check for the next one. So I don't want to separate them with new lines here. This looks logically one big block of code, right? So it's if, elif, else. You can have multiple elif blocks based on what all condition you want to check. Finally, optionally, you can have an else block. If none of the conditions are met, what to do next? That's the last answer that you get here. So if I try running this now, and if I try a number like say, let's try some random number, let's say 75. If somebody's age 75 is greeted as welcome Python wizard. When I rerun this and try maybe 120, somebody's age 120. Wow, Python rules because somebody age 120 is using it. Maybe you should ask, isn't it time for retirement? Okay, let's not be that impolite. If I try a number like say 300, definitely not a human, isn't it? Not in our generation. Not in our generation. I haven't seen any human being aged 300. They did tell me that age 300, they are lying. So, are you really human? You just want to ask it. Maybe he's a Superman. Okay? All right. So, this is how you use if, elif, else constructs. So, I gave a very silly example. In real world, you can do a lot of things. Consider an example where I want to fire up a request to some website, to a VPS, to some web API. I get a response. When I hit a request, I can get different response code. Sometimes the server might respond telling 404. resource not found. What do I do then? There's a condition check for that. The response code is 200. Okay, that went through very well, and I can process the response data. If the response code is a 300, maybe it tells me to redirect to some other site. So I need to do something else for that. Or the response code is 500. Oh, something failed at the server side. So I need to handle that separately. So checking for different conditions can be done using if elif constructs like these. And yes, whatever you have here is anything that can be evaluated in a Boolean context. I told you that every single expression, every single object in Python have a Boolean truthiness. So the objects, if they evaluate to true in Boolean context, then the block is executed. Otherwise, they are not. How do you check that? Suppose if at all I try a number like this, if I try another example here, let's say a is equal to 10. If a, I just put if a there. Some of you might ask, does it look valid? There are certain cases where it is okay to write code like this. Not here. This is just a small example. It's like telling if a has a value. That's right. That's how you read it as. If I say if a, I'm not trying to say a equal to 10, a equal to 20, and so on. If I just put if a, because a has a value, a number would have a value if it's not zero. Zero is like zeroness, nothingness for a number, right? So if you say if a, the print, a has some value. Some of you might argue that, oh, zero is also a value if you're a mathematician. But for normal use case, imagine your bank balance zero. Does it have any value? No. Right? So if your wallet is empty, what's the amount of money you have in your wallet? Zero. No value. Right? I want to check for that practical conditions like that. There use this, right? Not in the purest mathematical sense. Rather than calling it A, let's call it, money in wallet. That makes sense. Practical sense. Money in my wallet. You can have a variable that's this long, but don't create variables like these. Variables are like names, like the real names. If I tell you that my name is Chandrasekhar Babu, people find it difficult to call out my name, right? If your name is very long, it's made up of multiple syllables, and obviously, people like to have a shorter name. Called Chandra. Done. Right? That's how it is. So everyone who's got a very long name that goes like, say, 10 characters and above, if you spell it out in English, definitely would have some kind of a short name to be called, or a nickname, or an initial. Right? That's how it is. So when you're naming variables, don't name variables like these. These are painful to use. Painful. Right? So that's something you should know. So I say, if money in my wallet is 10, but I'm just trying to word it out like in English to just show you. If money in my wallet. Now it reads like English, isn't it? If money in my wallet, I have some value. I have something. Else, I have nothing. Well, nice. If I make it zero, I have nothing. What if I have minus 10? You can't have a minus 10 in your wallet, but maybe because you owe money to somebody. So your account balance is minus 10, right? So you owe money to somebody else. So that could be a case. Still, I have something. I owe somebody, right? So a negative number is also value. That means it's evaluated as true in Boolean context. So I'm just giving an example, right? But yes, don't create variables like this. Avoid creating painfully long name variables. Try and find out a trickiest small short name that can still mean what you're trying to indicate. If you cannot really name your variable with a short name, the variable is representing something that's way too complicated, right? So that's what it is. Maybe I should simply call it wallet. Wallet value. Wallet value. Money in my wallet is like an English word. I mean, sentence. Don't use sentences, right? Use some small nouns. Variables must generally be in English words. There should be nouns, right? Not action, not verbs, nouns. 90% of the time, I would say, right? So when you name a variable, the variable name should sound like a noun. It's like, value or temperature, or it could be, what else? It could be username, role. Mostly they could be like common nouns or sometimes even proper nouns. It can be a noun, but you don't want to name a variable like um, run. Run is an action. Run is equal to 10. Run is equal to true. Doesn't sound nice. Yeah, there are use case scenarios. Can run is equal to true or start is equal to true, but that's like a status variable. Mostly Boolean variables might represent action. Variables that look Boolean, that means the value is true or false. If the value is only true or false, they might sound like a verb. They represent some kind of action. Status is equal to something. Status is equal to true, right? So flag is equal to something. Flag is equal to, status is equal to, or run is equal to, start is equal to, stop is equal to. When you use that kind of variable names, they are mostly true or false. Mostly true or false. But mostly if you're representing verbs as such, actions, they could be functions. Functions are actionable things, right? They perform action. So names must be mostly verbs. But when you're having a variable name, you'd use a noun like that. So if you keep that clarity of thought, things are easier. If you cannot use a single word noun to represent a variable, your thought process is not very clear in representing the logic or the structure of your program. You need to think further and try to break it down a bit, and see how we can make things more simpler, right? If your name is going to be sounding very complicated, that means your code is going to be very complicated. You need to further simplify it. Your code should be focused on simplicity. So these are some of the refinements you should have in your designing code. Okay, so I digress. So come back to it. Come back to the conditions. I told you. So I told you how you can formulate conditions. I told you how you can create if-else conditions and how if else works, right? This is what all you need to know about if conditions. So you can use any kind of Boolean expressions and any objects that have a Boolean truthiness that makes sense to check. You can use that if condition and work accordingly, right? And whatever block of code you have, you can have multiple lines of code. You can have nested if conditions if you want to. Generally avoid it. See if you can avoid it. Avoid too many nesting of if conditions. If some condition is true, again inside, if another condition is true, inside, if another condition is true, doesn't read nice. It looks complicated. Our human minds, when you're trying to read the logic, the moment you go beyond two levels of nesting conditions, nesting if conditions, our brain starts to hurt. On average human being, I'm talking about, right? My brain starts to hurt the moment you say if some conditions met, some code, again, if some other conditions met, something else, and when you go to another level, the upper condition must be true, then this condition must be true, and this must be false. You can see the permutations that's falling up there, right? So this can lead to scenarios where you have to think of all the permutations of conditions, and it's possible there are some things that you wouldn't have thought about, and your code breaks right there. So keep your code as flat as you can. Avoid too many nesting of conditions. So if you want to avoid nesting, one of the ways you can do that is you can check both of these conditions at one level. If some condition is true and some other condition is true. For example, if I want to check, let's say, I want to check whether the age is an even number. The age must be less than 50 and age is an even number. Something like that, right? So again, I'll just copy this code. I put a C there. I'm going to press V to copy this code below. And here I can check if age is less than 30. And I'll also type age percentage 2 equals an even number. Only if that condition is met, you'll print hello in Pythonista, or otherwise I think you'll see what happens. If I try the age as something like, say, 23, you'll not be greeted as hello young Pythonista, but you'll be greeted as welcome Python Guru. Because you know why? This condition is true when I type 23, but this condition is not true. So what happens? Else is going to check for this condition. Oh, this condition is true, right? Because here it did not satisfy the condition completely because one of them is false. And if any one of the Boolean expression evaluates to false, the outcome is false. So therefore, this condition is not met. It's not going to execute this code, but rather it's going to check for this one now and execute that instead. These are some of the side effects you should be wary about when you're mixing conditions. So keep your conditional expressions as simple and straightforward as you can. If at all you have to think too many permutations to see how your conditions play out, you need to restructure your code. That's what I would always suggest. Always focus on keeping your code simple, right? Avoid unnecessary complexity in your code as much as possible. Okay. So this is how you can combine multiple conditions if you need to, avoiding nesting if necessary. Of course, in this case, you might say, maybe what I can do is that I don't want to execute this part. Maybe there I can use nesting. I can use nesting like this and then check it. Then the meaning is different. Just observe. Most common mistake. Most people do this. They'll say elif and whatever, and you forgot a colon here. If you forget a colon, it's a syntax error. These days is very intuitive. It says at this line, line number 5, expected colon. See, I missed a colon here. So put a colon in here. There are some common mistakes you'll make. Sometimes your tools like VS Code will highlight it immediately, so you can fix it. But if you're using some editors which don't have syntax highlighting and you miss it out and you get, when you run it and you get an error, you should be very clear about reading the error message, what error you get, which line number it is, and then find out what the error it is and go and investigate and fix it. Right? That's something you should know. Now, when you run this, you'll not have the side effect. If you try 23, you can see that if this condition is met, then it'll check for this condition separately. And then it prints, welcome young Pythonista. Right? In this case, it does not print it because 23, right? This condition is not met, it doesn't print any message. You can put an else clause here. You can put an else clause and print something else. This is a nested if condition, an example. I can put an else clause here and say, hello Python newbie. Maybe people who are having ages, which is an odd number, will be welcomed as a newbie, but otherwise, hello young Pythonista. Right. So if I try 23, if I try maybe 24, you can see the message has changed, right? So you can apply a lot of conditions and multiple conditions, but nesting is, you can see a nesting here. One level of nesting, no problem. Beyond 2 levels, that's where you have to think of all the permutations, right? Things get more complicated. That's what I mean to say. So what I'm trying to tell you, all of these are just guidelines, they're not like strict rules. You want to try to follow that as a guideline and see if you can make things simple. But of course, programming and go beyond a scale, it can get extremely complicated. It's inevitable at some point where you end up having, like, say, 4 or 5 levels of nesting conditions. Yeah, it's possible. So in such case, it might be inevitable altogether, right? Such cases, you have to test your code for all the possible outcomes, right? Anyways, so I showed you how what it takes to write if else conditions. I thought I will cover while loop and for loop in this video, but this video is spilling to an hour. Don't want to skip too much, or let's keep this constrained to only this conditional statement, if condition. I'll get another video where I'll talk about while loop, another video on for loop. So I'll keep them separate as such, right? So try this out. So try these examples out and try various outcomes. Think of any interesting logic and try it out, right? So right now I'm just teaching you basic stuff. I'm not giving you any exercises at this moment. I want you all to explore these keyword syntaxes. Try out with this keyword syntax, simple examples, right? Like these. So try of anything simple example that you can think of and try this, right? Once I finish about, let's say, a couple of flow control constructs, let's say I finish while loop, for loop, a little more about modules, one more layer on modules, I will give you a lot of exercises for you to practice on. All these will work together that way, right? Okay then, so hope to meet you in the next video where I will introduce you to the while loop. I hope you enjoyed the session. I hope you learned something. I hope you learned what it takes to form a compound statement, the role of indentation, how indentation works, And I also told you how to use if condition, if else, if elif constructs to actually formulate conditions, and how you can also treat any object in Boolean context and check them with if condition. So this is it for now in this video. So I will meet you in the next one. Thank you very much. And if you like this video, as usual, follow the YouTube algorithm, all the things that formalities of YouTube, right? Like, share, subscribe, and yeah, please comment if you have any further questions or doubts. Thank you very much.